Okay. So our break time is up. So let's come back to the slides. Let's move on to this slide. Physical layer from the detailed. From now on is the detailed explanation of every layer's job. Right. Let's take a look from the physical layer. So we don't have to in this part we don't have to remember all their job, all their information on this page. So we just focus on the keywords, key function of this layer. Right. This is the way we memorize these several sites. So for physical layers, it just defines the physical parameters that's going to use on the transmission. For example, it defines the voltage, voltages, interfaces, cable. What kind of cable you use? You use an Ethernet cable, you use a fiber, right? You use the serial cable or WAN cable. So what kind of cable you use, and how is the electrical feature of your interface and the electrical features of your network. So this is what physical layer do, right? So also about the distances and so on. So this is what physical layer do. And the typical media of physical layer is right now we know is a twisted pair cable. We know Ethernet cable, and also fibers, and also another one is called Wi-Fi, wireless line, double line. So this kind of media is also all defined by physical layer, right? Coaxial cables is already in the books. We do not use this already, right? This three, right? Ethernet cable, fibers, and Wi-Fi. So it's the typical ones of the physical layers definition. And for on this page, so we need standard. The information we need to memorize is mentioned just now: cable types, wireless, fibers. Also we need to know for the WAN cables, because we already the WAN cables we do not touch it very often in our daily work, but for the knowledge, or for the knowledge point, we need to know the last two. 𝗦𝗫24, 𝗦𝗫35, these two kind of cables name, and also the detailed perimeter in the following pages. Right, this is the typical type of media existed in the physical layer. And when talking about the name, you need to know which range it belongs to, right? Which range it belongs to. For LAN cable, it's like this expression. This kind of cables belongs to LAN, and this kind of cable belongs to WAN. And for WAN cable, 𝗦25, 𝗦𝗫25, 𝗦𝗫24, 𝗦𝗫35. These two cables are important. Right. Also the parameters we need to memorize. This is for physical layer. For data link layer, so we say this is the bridge between physical layer and the network layer. Right. It's between physical and real logic. So the job this data link layer is listed below. So what we need to memorize is because at this point of time, we still didn't touch any protocol on data link layer. So the protocol we don't need to know much at this point of time. So the keywords for data link layer on this page is to recognize, or to creation means to send, and that identification is to recognize the frame. What is frame? Is layer 2 on layer 2 on data link layer. The information unit is called frame, right? So it's actually make and recognize frame. This is the main function number 1, and maintenance the data link, release the data link, and also we need to pay attention to this one, flow control, because on data link layer have its own method of flow control. Why I pointed why I emphasize this one clearly, because in these 7 layers, there are 2 layers have flow control mechanism. The one layer is here, data link layer. Another layer is a transport layer. So these 2 layers have flow control. You need to keeping in mind, right? Flow control, but the method, the way they do flow control are different, right? This is the information, key information. Error control, CRC, for example, error control to examine whether the frame is correct or damaged on during transportation. So during transmission. So this is error control. Also addressing that when we're teaching about the switching protocol, we're gonna know we have a kind of address, right? The kind of address is on the data link layer. It's called MAC address. It's different with IP1, with IP address. So on data link layer, this also have this media was physical layer. Oh, sorry, not physical layer. It's a media oriented address. It's a called MAC address on Ethernet. Right? So on other type of the data link layer protocol, they also have other kind of addressing. So this is on data link layer, right? For as a summary, on data link layer is make and recognize frame, is do flow control, is do error control, is also have its own address. So if we see this vertically, for flow control, to flow control function, transportation layer and data link layer have flow control. And for addressing function, network layer and data link layer have address. So this is the information you can remember this, right? You can remember this only based on data link layer. You can also compare with other layers to remember the information vertically. So this is the information on data link layer. So about the information right here for LLC sublayer and the MAC sublayer. So we are going to teach this information later, right? Here, let's move on to, sorry, this is the data link layer's typical standard. So we don't have to remember the name one by one. We just see this, we just know this link layer standard or protocol mostly come out from IEEE, and they have their different definition due to different kind of protocol, right? For LAN is this big thing, and for LAN, HDLC, PPP are the main target we're going to learn in this training, right? It's in the last few chapters, right? Any questions? Oh, so if okay, I move on to the next part, network layer. So network layer, we already know this is a totally logical layer. So what this layer do is just two things. One thing is to do addressing, to do a logical addressing. Right? This is the main job of network layer, to define the address of every node in the network. Right? The second one is to find the path. The main job of this network layer is just two. Please memorize again. First one is to logically assign the address to every node on the network. It's just like when we say this, we just imagine that just like our real address in our daily life. So if someone want to find you, or someone wants to send you some parcel or packages, they need to know your address, right? They need to have your postal code. They need to have your actually address, which province, which country, which province, which city, and which block you're living at, right? So this thing in the computer network is called logical addressing. So network layer, the first important job for network layer is do the same thing like this, the similar thing, to assign an address for every node which join this network in order to find this node, right? To find this host or devices. So the second job is to find that. So this is important two information functions for network layer. Others, congestion control, interconnection of different, actually it's a different network. Why use this words? It's hard to read, hard to understand. Actually, it's the interconnection of a different kind of network, different kind of layer 2 network. For example, is different devices all can use IP address, can use IP protocol on network layer. But on data link layer, these devices could share one Ethernet network. You can also share one token ring network or FDDI network. So that means on data link layer there is an abundant, there's a lot of protocol, very abundant protocol on layer 2, right? On layer 2, but on layer 3, they can all share one IP network. So that means that's the meaning of this sentence, right? No matter which kind of layer 2 data link layer network is, they can also use the network layer. So that means network layer IP network support or is competitive with a lot of kind of data link layer network. So this is the meaning, right? So for here is just an explanation for you to easier to comprehend. Right? So this is what network layer do. So on this page is just to explain this page, just explain the information mentioned, the main job of network layer. The first one is giving an address, assign an address, right? The common use address system is IP address. This IP protocol is a common use in daily use, daily work, right? The IPX address is also used in some special occasion, but it's not a common use of daily work because it's very apparent that compared with IPX protocol, IP address is easier for us to remember and configure, right? So here we could remember the name of IP address. The pattern of IP address is called dotted decimal pattern, right? Because it's a dotted decimal pattern, it's very easier for us to memorize, configure. So that's why IP address is getting popular against IPX address, right? And no matter which one, IP or IPX, they also share the same structure. Structure. It's divided. This address are divided into network address and a host address, right? Network part, host part. One part indicate the network this address exists in, and one part shows the precise location that this node or this host exists in this network. So this is why it's divided into network address and host address, right? And a network layer address is globally unique. Here it mentioned a network layer address that mentioned here is pointed to. We just imagine it's the address on the internet, right? If your address exists on the internet, it must globally unique. For the reason we will explain more detail when we teach the following chapter, right? This is for network layer addresses or network layer function. And also another function for network layer is to find a path, right? I just mentioned the first one is assign an address to give everyone a ID card, right? An address card. And then the second job is to find it, right? How to find it. So here we imported the routing protocol and the routed protocol concept. So what's routing and what's routed? So we can take a look at this picture. We could see several hosts connected into the network. So the IP network, some segment use REAP protocol, some segment use OSI protocol, and all this dynamic routing protocol is used to calculate the path, right? Calculate the path. So this kind of protocol, which using their algorithm or using their mechanism to calculate the path and to let the devices in the network know how to find the destination. So this kind of protocol is called routing protocol because the purpose of this protocol is to find the route to the destination. So this protocol is called routing protocol. For example, REAP, OSPF, and BGP are typical routing protocol, right? Let me repeat. It's called routing protocol because this protocol is to find the path or find a route to the destination, right? So what is routed protocol? the routing protocol is the material or the ID routing protocol using. For example, no matter RIP or SPF, they calculate the network, they calculate the path, and the final information they indicate the path is the IP address, right? The purpose they calculate is to find the destination IP address. So the material they're using is IP. The target they're calculating are IP. So the IP is calculated and the IP is routed. So that is why it's called routed protocol. So the understanding is, again, it's pretty easy, right? So routing protocol listed here. For routed protocol, two kinds, right? IP or IPX, right? This is a routing and routed protocol. Here I mentioned the connection-oriented and connectionless services. Actually, it's I think it's to me it's a little bit earlier to mention these two concepts to you, but at this point. So because it's the most of the detailed information is mentioned on chapter number 6, I think, TCP and UDP. So for if we just mention a concept, is the connection-oriented service means when I deliver some message to my destination, every time I need to build a connection at first. I need to say hello at first. Hi, I'm here. I'm 𝗟𝗜𝗏𝗘. I want to send you something. In the following seconds. So how about you? Do you accept or not? So this is this thing I'm doing before sending the information is building the connection. So after building the connection, I send the information, and after you say, "Oh, hello, I accept the connection you want to build. I accept your hello," right? So and then after this connection is built, and after this connection is established, and then I send the real information to you. So this kind of service or this kind of pattern of communication is called connection-oriented service, right? Must have a connection before sending the data, right? So this kind of service have its advantages because it's more reliable than the next one, right? Because I build a connection, I could resolve the problem of error retransmission. I can also acknowledge every data transmission. So that's very reliable. But the disadvantage is the delay. The delay is involved more delay because I need to build connection before sending the information, right? So on the contrary, the service without building connection before sending the data is called connectionless service. So this is the best effort service because of no connection built. The speed is quick than the former one, but the disadvantage is not so reliable. No sequence mechanism, no acknowledge, but all because of no connection. So if mention one more step ahead for connection-oriented service, we could see this. We will learn this as TCP protocol, and connectionless service we will learn this as UDP protocol. So just for your information, right? So this is the concept, only the concept for connection-oriented and connectionless. So if you confront with some question in your exam, just remember their advantages and disadvantages, right? Reliable but slow, not so reliable but quick. So this is how we comprehend this. And network layer protocol operation. On this picture, please pay attention to the following sentence. On this picture, it shows the procedure or the process on host and routers during the data transmission. So I already limited the condition very narrow condition. So this picture shows the process of a host and router during data transmission. Right? This is the condition, or this is the circumstance. Right? So under this circumstance, we see host A communicate to host B through the network, which consists of 5 routers, right? So when host A sending out something, we still use the Outlook example, right? They're sending out the email will be preceded by all the layers, right? By all the layers from application to physical, and send out on the line, on the cable, by bit stream, and to router A, right? Router A de-encapsulated information to data link layer, to network layer. We see here, router A will not de-encapsulate for more layers, right? You just de-encapsulate by network layer because the router is not the destination, right? The destination is B, host B. So all router on the network will recognize this. Oh, the destination is not me. It's just using my information to find a path. So under this circumstance, the router will just de-encapsulate all the information by layer 3, by IP packet, to find the destination ID, destination IP address, and forward the packet due to the information on the router, right? Because the router already found the path, right? So send out the information again by bitstream to router B. So router B will do the same, de-encapsulate by network layer, and so on through router C. Finally, to router host B will de-encapsulate up to application layer, because host B is the real destination. So destination will de-encapsulate to the final application layer. So this process finished the job between the communication, finished the communication between host A and host B. And in this picture, I already mentioned very carefully, is this the picture of the condition during data transmission, and router only, and sorry, let me make this straight, put it straight in this way. First one information is, this is the picture, this is the flow during data transmission. The second information is only the sender and the receiver, or only the source and the destination solve or deal with all the information from layer 7 to layer 1, right? The other devices, other routers on the network, which is not the destination, only deal with the information by layer 3, by network layer, right? To deliver the packet or deliver the bit stream online, right? Finally, it's a bit stream, right? But logically, it's the packet, right? This is the information number 2, right? Only destination and the source solve all the information from layer 7 to layer 1. The routers only solve the information by layer 3, right? This expression works, or this expression is correct only under this circumstance during the data transmission, right? So also this picture shows how this thing works, right? How the workflow is. Then transport layer. Sorry. Transport layer. Its main job is divide upper layer data into segment. It's a TCP or UDP segment, and establish end-to-end connection. Here is mentioned when the upper layer protocol use the TCP, actually, is a need to build the end-to-end connection. But if you use a UDP, don't have to, right? And deliver transparent and reliable transmission. And see this, perform flow control. Once again, anybody could answer me on which layer flow control have flow control function, besides transport layer. Let's do a recall.
Layer 2.
Layer 2, right? Perfect. And which layer do the dressing?
Layer 2 and 3.
Layer 2 and 3. Perfect. I think it's a perfect answer. Mentioned by Wei-Zhi, so I think you give the perfect answer. Could you type down your name on the chat box so Wei-Zhi and Shura will make a record? Thank you very much. Then, so this is the key information we together give a review, right? For the flow control, transport layer, and the data link layer have flow control. Method are different. So we are going to teach this later. Okay, for transport layer, TCP, UDP protocol are the typical protocol in TCP/IP protocol stack, and SPX is in IPX and SPX protocol stack, or you call it protocol stack or protocol suite. Okay, so the common used one is the TCP and UDP because it's in TCP/IP, right? Okay, for session layer, presentation layer, and application layer, actually not. It's closer. It's close to the user point or user side, but actually, what we can feel or what we can touch is the application layer. It's more specific to us. For example, it's SQL, NFC, or just mention Outlook. Is the Outlook or is the WeChat, or is the other application, for example, you using the other application to see a movie. So this is called application. So this is more specific to us. For presentation layer, the job is more about format and do the encryption. Right, this is more about presentation layer. So here, one key point: if mentioned encryption function exists in presentation layer of OSI model, right? And for session layer, session layer is a more actually its meaning is literally on this layer's name. It's a build a session. What is session about? For example, we take example when we browse or we surf on some website. If we just let's say we go to Amazon, for example, to buy something. When we find Amazon's IP address is on network layer, right? It's Amazon's IP address. But when we visit this website, we need to build a connection to let the Amazon's website know this connection is from me, it's from Terence, it's not from Wei-Zhi, it's from other person, other users. So this is what connection do, right? But for session, what session will do? For me, for example, I go to Amazon, but I don't want to buy one product. I don't want the result that I can only buy one product at one time, right? I can only browse one product at one time. And maybe I open several tabs. I browse several products at one time, right? So this what session will distinguish, will tell the difference, right? You can see same person, same IP, right? Between me and Amazon, and my connection is the same, but I can have different session to visit or to browse different information. So this is what session do. This is what session do. Right. So maybe the presentation layer is a session layer is a little bit abstract to you, but the main job, the difference is session layer is about session, right? The presentation layer is about format, and for encryption is on presentation layer. Right? So this is what is about for these three layers. Right? We remember this in the group because later in TCP/IP they are all in one layer. TCP/IP here. Speak of the devil. TCP/IP model. So here we can see TCP/IP model is out of OSI reference model. And compared with the OSI reference model, TCP/IP did some job to simplify the model. It combined the TCP/IP model combined 7 to 5 these three layers into application layer, and transport layer and network layer is the same, and to combine data link layer and physical layer into network interface layer. So it's do some simplification job, and to make us more easy to understand and more easier to remember, and also easier to realize in the daily use. Right? Because the TCP/IP is out of OSI model, so the function is similar. So here we only take a look at the typical protocol or typical function mentioned in TCP/IP. For internet layer, which is the network layer on OSI model, the typical protocol IP, ICMP, IGMP, right? And they also do routing and route maintenance. It's the same function, a similar function as the network layer of OSI reference model, right? So as for the protocol belongs to this layer, we just remember the name. IP we already learned just now. For ICMP, IGMP, we will teach you in the following chapters. They all exist on this layer. Right. Transport layer, typical use protocol only TCP and UDP. Right. The job also error retransmission, fragment, reassemble, and also do the checksum to examine the segment's reliability. Same function as transport layer. Application layer combine all the function of OSI reference model from layer 7 to layer 5. So question is, if mentioned, we need to pay attention that for TCP/IP model, application layer already combine the three layers together. So all the function for TCP/IP model, all the function of these three layers from layer 7 to layer 5 exist in application layer of TCP/IP. No matter I talk about the application itself, or encryption, or building the session, they all in application layer of TCP/IP. So this is the point we need to pay attention. In other words, when you answer the question of the different layers function, the first thing is to take a very careful look which model this question is asking. Is OSI or TCP/IP? And tell the difference between the names and tell the difference between the layers, right? So this is important. Right? Network interface layer is from layer 1 and layer 2 of OSI model. Typical protocol is here. So in our teaching, Ethernet, in ccna, Ethernet, HDLC, PPP is the one we're going to learn. For other protocols, most of them is in the books, so we just know the concept first. Right. As a summary, most important one, we take almost 2 hours by here. OSI reference model, TCP model, we have finished the learning of this part. So very fundamental, but very important. So we take a full look of the layer 1 to layer 7, OSI reference model. Remember every layer's name, every layer's function, and to fully comprehend the peer-to-peer communication, which layer is logical, which layer is physical, right? And to know the sequence, when you do the communication, the sequence of the computer is to do the how to do the encapsulation and do the de-encapsulation, right? This is all the key information in OSI reference model and TCP/IP model. So that's the end of this chapter. Question time. Any questions?